Hey everyone, welcome back. So, have you ever stopped to think about how a program actually thinks? How it makes choices, responds to what you do, and just seems to know how to handle different situations? Well, today we're going to pull back the curtain on the C programming language and see exactly how we can give our code the power of decision making. This is going to be fun. Let's get started. So, let's just start with that big question right there. How on earth does a computer program decide what to do? I mean, how does it know to show you a login successful message versus a password incorrect warning? It's not magic, but honestly, it's pretty darn clever. The secret really is this concept called control flow. And you can pretty much think of it as the program's brain or its central nervous system. It's the whole set of rules that directs which way the program goes, telling the computer which lines of code to run, and, just as importantly, which ones to skip, all based on certain conditions. This is what turns a static script into something that feels alive and interactive. Okay, so here's how we're going to tackle this. We're going to build our own little decision-making toolkit, piece by piece. We'll start with the very basics of logic, then get into the classic if-else statement. After that, we'll see how to handle a whole chain of choices, look at a cool alternative called switch, and then wrap it all up by figuring out when to use which tool for the job. All right, first things first, before a program can ever make a choice, it has to be able to ask a question. And I mean, this is it. This is the absolute bedrock of all logic and programming. So how does a piece of code ask a question? Well, it uses these things called relational and logical operators. You've seen them before. Things like the double equal sign to ask, is this equal to that? Or the greater than symbol. Or maybe a double ampersand to ask, is this true and is this other thing true? The goal of these operators is just to ask a question that has a simple black and white answer. True or false? Now here's the crucial part. This is how C understands the answers to those questions. It is beautifully simple. If the answer to a question is false, C just sees the number 0. And if the answer is true, it sees a 1. Or actually, any number that isn't 0 works. That's it. That one simple rule is the key to everything else we're about to talk about. Okay, so our code can now ask a true or false question. The next step is to give it the power to actually do something based on the answer. And for that, we bring out our first and most important tool, the if-else statement. Just think of it like a fork in the road. The logic here is it's just like how we talk. The if part asks a question. If the answer is true, the program goes down one path. The else part is the backup plan. It's the path the program takes if the answer is false. If this is true, do this, or else do that. It's that simple. And here's what it looks like in the code. You've got the keyword if, then your question, the condition, goes inside parentheses. If that condition turns out to be true, the code inside the first set of curly braces gets executed. If it's not true, the program just skips right over that and runs the code inside the else block instead. It's super clean, super logical. So let's make this feel real for a second. Let's say we're writing a program to check if a number is positive. If the user types in 10, the condition number greater than 0 is true, right? So the first block of code runs, and maybe it prints positive on the screen. But if they type in -5, that condition is false, so the program jumps down to the else block and prints not positive instead. See? A choice was made. Now that simple fork in the road is awesome, but let's be honest, life is usually more complicated than just two options. So what do you do when you have a bunch of different possibilities? For that, we need to build a chain of decisions. And this is where the if-else chain comes in. You can think of it like a waterfall, or maybe a checklist. The program starts at the very top and checks the first if. If that's not true, it just moves on to the next else if. And it keeps on going down the line until it finds a condition that is true. As soon as it finds one, it runs that block of code and then, this is important, it skips the rest of the chain completely. The absolute perfect example for this is a grading system. The code asks, is the score above 90? If yes, great, give him an A and we're done. No? Okay, else if the score is above 80, give him a B. Still no? Okay, else if it's above 70, that's a C. And if none of those conditions are met, the final else at the bottom acts as a catch-all, maybe assigning an F. It's just a clean top-to-bottom process. We can even take this a step further and put one decision inside of another one. This is called a nested if. A login screen is a great way to think about this. First, the program asks if the username is correct. And only if the answer to that is yes, does it even bother to go inside and ask the second question, if the password is also correct. You see? One check depends entirely on the one before it. Okay, so these if-else chains are clearly super powerful, but for one very specific kind of job, there's another tool that's often a bit more elegant. It's not a replacement. Think of it more like an efficient specialist for checking one variable against a whole list of possible values. And that tool is the switch case statement. Its entire purpose in life is to take one variable, say a user's choice from a menu, and then compare it against a list of preset case values. When it finds a case that matches the variable, it jumps to that spot and runs the code. This thing is absolutely perfect for stuff like a calculator menu. The program would switch based on whatever number the user typed in. If it was case 1, maybe it runs the addition function. If it was case 2, it runs subtraction. It's not just that this can be a lot cleaner to read than a super long if-else-if chain. A lot of the time, the compiler can actually optimize a switch statement to run faster. So it's a win for both readability and performance. All right, so we've got if, else if, and switch in our programming toolkit. Now comes the most important part. How do you know which tool to grab for which job? Let's do a really quick side-by-side. Look, the if-else structure is your all-purpose, super flexible multi-tool. It can handle any kind of comparison you throw at it, greater than, less than, complex combinations with ands and ors, you name it. Switch, on the other hand, is a specialist. It does one thing, but it does it incredibly well, checking for equality against a fixed list of values, like whole numbers or single characters. And before we wrap this up, let me save you from some future pain by pointing out a few classic mistakes. First, mixing up the single equals sign, which assigns a value, with the double equals sign, which asks a question. Huge difference. Second, forgetting your curly braces around code blocks. That'll mess up your logic every time. And finally, the most famous mistake of all, forgetting the break keyword in a switch. If you do that, the code will just fall through and keep running the code for the next case too, which is almost never what you want. So if you only remember one thing from all of this, let it be the simple rule of thumb. When you're checking for ranges, like a grade between 80 and 90, or when you have really complex logic, if-else is your best friend. But when you're just checking one variable against a specific list of options, like menu choices 1, 2, or 3, switch is almost always going to be cleaner and sometimes even faster. And there you have it. You now have the fundamental tools to make our programs react, adapt, and basically think. You can guide them down whatever path you want based on user input, data, or pretty much anything else. So the only real question left is, what are you going to build first?